Hello everyone and welcome to Copernicus Marine Service training number 1 about Atlantic Ocean, or more precisely about Northwest European Shelf region of Atlantic Ocean. My name is Daria, I'm from Novelties, and today I'm here to present you this QGIS training and to show you how to use Copernicus Marine Service products to study such a phenomena as river discharge and also estimate the impact of such phenomena on marine environment. A quick word about Northwest European Shelf. This region is a large area of shallow waters, shallow seas, which is a part of Atlantic Ocean basin. And as we're going to focus on river discharge phenomena, river discharge is basically all waters which are brought to the ocean by rivers. And since these rivers, they flow through the inland terrain, they will not only bring fresh water to ocean, they also bring many other things, such as debris, different types of debris, as vegetation debris or man-made anthropogenic debris. They also can bring a lot of different chemicals and nutrients, as phosphates and nitrates. So eventually, all these things will end up in the ocean. And it is known that specific concentrations of different nutrients, such as nitrate, for example, are actually beneficial to the marine environment because they boost the growth of marine plants, which are source of food for marine species. But it's also known that ex excessive concentration of the same nitrates can actually severely damage marine environment. So today we will learn how to study, how to analyze these phenomena using Copernicus Marine Service products and QGIS software. So first thing we're gonna do is of course to open QGIS tool itself and create a new project, empty project. And we're going to add our first layer. This is a map, the background layer. We go to Layer tab, Add Layer, and choose Add WMS layer. And here we already have some pre-loaded layer, which is called VMS server. And we will need a blue marble world, which we just add. And now you will see that, yes, now we have a background, the world map. As you may notice, when you just start with QGIS, you may not have uh, this layer. So to add it, you first click on New. You put here a name, so it was a map server demo, for example, and you put an URL, so the link to this layer, and this link is given in the PDF tutorial of this one training. So go there, go to the part of uploading, downloading the creating a new layer, and copy it here. And when you have name and URL, you click on OK, and then you click on connect. So for example, now we just refreshed the page, and yeah, but as we already added, we just close it, and now we have our map of the world. So next thing that we're gonna do is of course study our river discharge, and the first things that we're gonna start from, we will start from detecting major river discharge sources here in Northwest European Shelf. Northwest European Shelf is primarily this region. You will see it later. And to do so, we will add our NetCDF file, which we previously downloaded from Copernicus Marine Service website. How to download these products, you will also find the information about it on the Copernicus Marine Service website, and also some examples you will find in the PDF tutorial of this training. So what we're gonna do, we're gonna open the NetCDF plugin, which was created specifically to allow users to easily work with different NetCDF files here in QGIS. We click on it, and to have this plugin, to obtain this plugin, you can follow to the you can go to the PDF tutorial adjacent to this one training, and you can find all the instructions on how to obtain this plugin and how to um, set it up here in QGIS. So what we're gonna do now, we're gonna add our data. So for this, you can click on plus and just browse to the place you want, the place you need. But you also can do it through, for example, here I have my folder with different data. And what I can do is I can just choose one I need. I need the salinity, so this one, and just drag it and drop. And I also can do it with others files we will need later. I will show you it after. So you see it's gonna be like that. Okay, so now we have our files. We have three different NetCDF files. This one is about salinity. You can see seawater salinity. This one is about mole concentration of nitrate in seawater, which we will study in the second part of this training. And in the third part of this training, we will study the current field of a region. And for this, we will need seawater velocity components. So let's go back to our first exercise. And for this, we will first map our first variable. So salinity. We click on salinity. We choose seawater salinity, which is here. We right click on it, and now we have add layers or sequence layers. So now here you can choose both, like one of them or both, but we're gonna go just for add layers, which is the main difference that you probably already know. I still mention the sequence layers allows you to see the animation of layers switching between each other. So we go to add layers. Additional window pops out, and now we're gonna choose our data like our time frames, which we're gonna use for our project. So here you can see that we have different dates of April and May 2020. So we're gonna choose so not to overuse a lot of time frames. We will choose basically one data frame per day per 15 days. So we can see that here we have every day at 12, basically at noon. So we're gonna choose each 15 days that time frame. So first we're gonna click on the 1st of April, then we're gonna click on Control and hold it and choose 15. We click on it. We continue pressing Control and we go for 30th of April. Then we go for 15th of May and 30th of May. Where is it? Okay, 15 and 30. Okay, good. We chose several time frames. We choose the depth. We choose 0 because we need only on. You can choose whatever you want, but we want exactly on a surface. Here the group we will rename it. We'll call it salinity. And that's all. We click on add and close. Okay, now we can look at our salinity layers. So here, let me adjust a bit. Here on the layers tab, you can see all the layers you added. For example, you see the blue marble world. For example, you can untick it, tick it again. You can also, well, yeah, here you cannot see anything. This is our salinity group, which we added. It has, as you can see, 5 time frames. I all ticked in right now. So this is what we can see is from April 1st. If we untick the box, next one is going to be 15th of April, 30, the May, and so on. Oopsie doopsie. So, we continue. And now let's change the style of the layers so to have a better representation of a layer. So to do so, we right click on one of the layers, doesn't matter which one, and we go to properties. In properties, in symbology, we start to tune. So first what we're gonna do is we're gonna set the min and max of our colors, of our values. Here you can see that it's 3.3, so let's set 3. Here is 35.9, so let's set 36. Now we have more neat numbers. What we're gonna also do here in the mode, you change from continuous to equal interval and choose 5 classes. 5 classes should be enough. So that's basically it. So you can see here, you can, for example, use a different, oops, not here, color map ramp, different colors. And what we're gonna do also is uh, we're going to we're going to apply all these tuning options. We make sure that we can invert color ramp, for example, but we will stay with this. We click on apply. Okay, and okay. So now you can see that the style of the layers changed. Here we can even see the the bar of which color corresponds to which concentration. No, sorry, to salinity. Well, yeah, salt concentration in water sea. And here you can see, for example, that here it's less salty than, for example, here. So now we're gonna spread all this tuning from this one layer to all others. To do so, we right click on this layer, we go to styles, copy style, and then we choose all others by again we hold control and we choose, or we click on first, we hold shift and we choose the last, and all of them in between also chosen. We do right click and we put paste style, sorry. So now we can, yes, now we can see that all our layers have the same style. So now as we see the salinity level of a region, now we can identify major sources of fresh water, because here where we see that the salinity is the lowest, it means that here we have fresh water um, flowing into the salty water of the ocean. So now what we want to do, we want to mark these parts, these regions. And to do so, we first need to add a specific plugin. So we go to this panel, plugins panel, and click on manage and install plugins. New window appears. We go to all, and in search bar we put numerical digital, okay, yes, numerical digitize. It's already here. So what we need is this one. What we do is we click on install, we wait a bit, and close. So it is finished. Now a new plugin is on in our project, in our QGIS. So what do we have now is we have these two new buttons which belongs to this plugin, which we can use. So for this, to use these buttons to create our points, what we need to do is first we need to add new layer. To this we go layer, create layer, and we create new shape file layer. We choose geometry as a point and put a name, and we put a name point extraction, oh, almost extraction. Okay, we save, and voila voila, it's good. So okay, now we have a new layer. It was added a bit in the group, so we just can actually, okay, drag it up. So now we have our new layer. So what we can do is now we can edit it. So we choose it among our layers. We click on this pencil, which is toggle edit mode. And now we have these two buttons active. So what we do, we also have this. This we will use a bit later. First, we will use this one, which is add point feature. So we're gonna use it to add different points. And to do so, we click, and now we can choose. So you can add as many points as you want. In the tutorial, which is presented in a PDF file, you can see 8 or 9 points. So here we're gonna do it less, I guess, so not to spend a lot of time. So we put, for example, here. Now we need to put ID. I'll start with 1. Okay. So next, let's put 1 here. I will put 2. Wherever you want. Of course, I try to put it basically on the less salty places. Pop up. It was free, so let's put here number 4. Where else? This one is the least salty place. It was 5 if I'm not mistaken. Yes. Let's put one, I don't know, here. It's gonna be 6. Uh, yeah, let's finish on that. So now we have all these points, we added them, and now what we're gonna do is basically save it. How we do it? We just click on this again, and it asks us, do we want to save? And yes, we do save the changes. So now we have our points. We can change the color of our points, for example, because right now they're not really visible. I don't know, let's put red, not really, blue, no. Uh, yeah, okay, so let's put them in pink. Good. Uh, so we added them by this, we added them manually, but also if you click again, you can use this exact tool to add points, like here, to add points manually by putting the coordinates of points if you know specific points of interest, for example. And with this tool, you can later, like choosing the points, change the coordinates and move them around, like correct the position. So as we go back, now we identified our major points, major sources of fresh water. So on this, the first exercise is finished. Yes, it was small and just a preparatory one. So now what we're gonna do, we will study the how we will study concentration of nitrate in these river discharges. And to do so, we of course need a new variable. We need to map a new variable. Now it's gonna be nitrate variable concentration. So we go back to our NetCDF plugin. It's already open. And here we go back to NetCDF and we choose our nitrate, mole concentration of nitrate. We have the alt value. Again, right click, add layers. So what we're gonna do is we're gonna again add the same time frames, once 15 days, to match with the ones we already have. Okay, should be 5. Depth the same. We will save a group as NO3. If you want to change, you're free to do so. Add and close. So now we have our new layers, and let's untag salinity. So now we have the nitrate. You see it's now on, and we're gonna change the style of a layer again to see better the representation. So we go back to properties, and again we see the minimum is 0 is enough. Here we put 185. Again, I will do it quickly. It's the same exactly the same procedure as it was before. So what we're also gonna do is let's change color ramp just for fun. Let's choose I don't know, magma, and go from inverted from light to dark. Let's apply to see how it looks. Okay, now why not? Okay, so now we see the nitrate concentration in the seawater. What we also will do is, of course, go to styles, copy style, and again do the same procedure we already done. Paste style, good. Let's check that everything is pasted properly. Yes. So now what we have, now we see the nitrate concentration in seawater of during April 1st, 2020. And what we can see, actually we cannot see our points because now, for example, we don't see the points because they are below the layer. So let's again drag them up. So what do we see now? We see that here, for example, mostly the high nitrate concentration regions, they are coherent with low salinity regions too, right? For example, here and here we can see it, but also we can see much more high nitrate concentration regions than we saw before with salinity layers. So, for example, and also here, you remember we put a point because the salinity was less than the rest of the ocean here, but we see that, for example, nitrate concentration is not very high here. So you are free to play with that as you want. You can add more points to all these regions. You can remove this point, for example, um, if the concentration of nitrate is too low, or like here, for example. It's up to you, but we're gonna stay with that, so not to lose the time. As we have our nitrate concentration on the whole region, let's now narrow down the analysis to some specific sub-region. And for example, let's choose some coast, for example, this part. And to do so, we first need to create a polygon. And after clip our raster layer, because this layer, the layer of with nitrate concentration and salinity, like all the layers with this symbol is raster layers, and we will clip this raster layer to using our new polygon. So to do so, we need to create a polygon, and first we go and to layer, create layer, new shapefile layer. Here we choose the type polygon, and I need to choose a file name, of course. So we call it new polygon. Nothing very creative. So new polygon, okay, good. We click on OK, and we have new layer here, but nothing is displayed because, oh, sorry, nothing is displayed because it's well, we didn't create anything yet. So what we do is we highlight the layer. We click on edit mode, we toggle it. Now we have a lot of options to work with. What we do is we choose add polygon feature here. Now what we can do, we can create any shape polygon as you wish by just clicking. For example, let's start here. So here now you have a line. So let's go to, for example, here, and then here, and like this you can gradually create your own polygon. So I'm gonna stop on that. You can create some other shape, you can make it bigger, smaller, whatever you want. And to finish, I do right click You see, now it's closed. And I put some ID. Well, it doesn't really matter. I put 0. And now our polygon is created. So I close the editing mode. Of course, I click on save to save all the changes we brought to the layer. And now, as I have it, what I want to do is, this is just a polygon. So it has no information in it. It's just some geometrical feature, geometrical shape here. What I want is, I want this part, I want basically this layer with all this data, with all these beautiful different colors and values, but I want it on this exact area. So to do so, I will go to raster tab, go to extraction, and clip raster by mask layer. So now we have this pop-up window, and here you have input layer. So in input layer, since we clip raster, it should be a raster layer, and you can see different layers. So what we're gonna do is we're gonna choose one of any nitrate concentration layers on these days. Any time frame you want. I'll choose the first one, 1st of April of 2020. And as a mask layer, I need a polygon, of course, some vector layer. And we have only one, but yeah, new polygon. What I also need to do is to choose the CRS, which is only one. This is coordinate reference system. This is actually the coordinate reference system we use here in this project. This is APCG 4326, and to know what is exactly the CRS, the coordinate reference system of your project, is actually depicted here, if you can see. And also on the layers, you can wait, where is it? Up. Okay, set CRS. You can set another one if you want, but we don't use it here because we are good with that. Some message popped out. I don't think it's something important right now. So, so we put the CRS. Good. And now we're gonna put keep resolution of input raster. So the resolution of our new layer, our clipped area, is gonna be the same as the original raster layer. And we need to save it to temporary file. Saved file. Oop. So yes, I just quickly chose the right path to the directory. It was lost by some, I don't know, some reason. So what is it? Okay. So the name is, for example, area clipped, because it's an area and it was clipped. Okay, we save it. And now what we do is we just run it, puff, and close. So now we have another area. Oh, I actually mistaken here, but okay. So I pull it up to see it now. I will like untick new polygon, and now we see this part of our last layer, what was cropped by the polygon, what we created ourselves on this specific part of region, the specific coast. Here, what we're gonna do is we're gonna copy the style again of the layer of this one, the one we had before, and we're gonna paste it, because as you can see, our new layer, our clipped area, has a specific its own style, and it's not really pretty and not really understandable for us, so we paste style. Okay, good. This we can close. So to make it easier, we will untick this. Okay, and now we can see exactly our raster layer which was cropped, and now only this region. Actually, as I made a mistake here, what we can do is I can show you what you actually can rename layer the way you want. I want it properly, area clipped. Great. What you can do also, you can duplicate layer, for example, is basically the same exact layer with the same shared source, shared data, everything is exactly the same. I will remove it now because we don't need it, so you can remove layer, yes. What else you can do is, yes, duplicate, copy, set CRS. As I told you, you can also export. For example, you can export the layer in different formats. You can export it in, where is it, in CSV file, so comma separated values. Don't really see it right now. I don't know how, but I really don't see it. So probably it's a version of wait, see, export. Yeah, you can, yes, you can see, yeah, because, yeah, I'm stupid, sorry. So yeah, you can save it if you want. What I wanted to show you is actually another one is for, I don't know what's happening with Python. So with new polygon, what we can say, what we can do, we can save. We can export, save features as, yes, okay, here you can use a geo package, which is also widely used um, for the same, basically, the same features as for QGIS and other tools like this. You can save it comma separated value, and you can also save it as shapefile, for example, to use it for future, for in different projects or whatever. Why couldn't I save it here is because it's actually a raster, and raster layer doesn't have any attributes. For example, you see there's no attributes, and here we have this, we have attribute table. We can open it here. As we have only one polygon that we created ourselves, it has only this one feature. The ID is 0 because I set it, if you remember, and there's basically nothing. But that's not limited by this. So let's go back to our exercise. So we now have clipped area, and what we can do now is to extract the data. I actually don't see the point. What I want to do now is extract the data from this layer, from this raster layer. I want to extract it on the points that we created. So for example, I want to know what is exact nitrate concentration here on this point, here in this point, and for example here there is no intersection with this raster layer, so it's going to be 0. And to do so, we're gonna explore some new tab which is called processing. So processing tab, it is here. We click on it and we choose toolbox. So toolbox is, as you can see, a very big tree of different functions, different features, options. It has actually a lot. And what we're gonna use is raster analysis. We're gonna find, okay, raster analysis here, and sample raster values. So we click on it, double click, and this algorithm creates a new vector layer with the same attributes of the input layer and the raster values corresponding on the point location. So basically what we choose as an input point layer is our point extraction, and raster layer to sample, we need to choose a layer from which we want to take the values and attribute them to the points we created. So you can choose basically whatever you want. You can even check salinity, any nitrate concentration one, but I want to extract values exactly from the clipped area raster layer, so this one. And let's now not save it to a file. Let's just see how goes. So we click on run. Okay, it's done. We close and we see that we actually created another set of points, which is basically the same points. If you look, oopsie, if you look here, it's the same points. But now what we have, and the name is sample points. This is default name which is generated. So what's changed now is the attribute table. We open attribute table, and now we see not only the ID of ID of our points, but also a value. So here you can see, oh, actually you could change also a value. Okay, let me quickly redo it. Let's remove a layer and do sample raster again. Okay, point extraction, area clipped. Yeah, okay, it wasn't shown, so I forgot about to do it. In other version of QGIS, it's more evident. So as it was a concentration, let's put NO3 concentration. We run again. Okay, so we have basically again the same points. We open attribute table, and now we see our points, and we see that 4 of them actually have some values and 2 of them have nothing, because if you see here, you will see that 2 of the points, they actually don't intersect with our clipped area raster layer. So what we do, I bring attribute table back. Now we see the concentration of nitrate concentration in these points. For example, if you go to the initial points and open attribute table, you just see the ID. There were no additional information on it. So as I said, for example, that we did not save it to a file, and now we have this layer, and here we can see this little icon which says temporary scratch layer only. So it means that after we close the project, all this layer will be lost. After reopening the project, you might see the window asking you, do you want to keep unavailable layers? And if you keep yes, say yes. All the layers, they will be kept, but you only see them in here in a layers tab, but you cannot see them on the map, so they're not displayed because they're not active anymore. To prevent this from happening, for example, sometimes you don't really want to save all the layers, and it's okay, but if you don't want this to happen, you need to save them. Save all these layers when you create them, or if you forgot to do so and you already created it, you can save it afterwards by clicking on this icon. And here, let's we have the same what I already showed you. So let's save this layer as a shapefile. We choose a file name and how we would call it, concentration, I don't know, NO3 concentration, no mistakes now. Okay, and basically that's all. We create on OK. Oh, it's saved, and now we have it. Good. Up. Yeah, you see, icon just disappeared. So now we have it saved, and yeah, it won't be lost if we close the project. So next, what we're gonna do is to actually, for this we need our attributes table again. Where is it? Yeah, it's here. Now we're gonna perform some calculations here in the attribute table, and yeah, I'll show you how to do that. As one of our goals, or the goal of this training, is to estimate the impact of river discharge on the environment, on the marine environment. We study the nitrate concentration, and we want to know if this nitrate concentration is higher than the norm. And to do so, first what we need to do, for example, okay, so we have these values, right? We don't know exactly what is the units, but actually this information it's kept in the NetCDF file here. Okay, now we here when we see that it's actually mole concentration. But let's assume that we found the nitrate concentration norm value in the internet, and it says it is 10 milligrams per liter. 10 milligrams per liter, and we have mole concentration. So what we're gonna do is we're gonna convert these values, which are in this is mole concentration. We're gonna convert it to our milligrams by milligrams per liter. So what do we do? Here we go to in attribute table. We go to this little icon, open field calculator, and now this tool allows us to add. As you can see, it allows us to add a new field, create a new field. In this new field, you can choose an expression, you can put any function. Yeah, you can write some function, some code. You have a lot of already a lot of options. So yeah, you're free to create and to play with this information as you want and create some other expressions. What we're gonna do, we create a new field and we're going to put it concentration milligram per liter. We're gonna choose a real number because it might be not so neat. And let's put precision 5, for example. You also, as you can see, you can update existing field. If you already have some field, you can update it with some other formula and so on. So now, here in expression, we will put a formula of conversion to milligrams per liter. And this formula is as follows. Let me copy it. Oh, it's here. And it says it's is invalid. Yes, and why? Because it does not know what is this value. So let me make sure. Oh, oh. So yeah, now it's valid. It's just it was missing something. So now you can see that the expression is valid, and we have output preview null, which is no surprise because the first one is the first line has no value in it. So we click on OK, and here now we have a new column added with new values, which are transformed from this column to this with the expression we chose. And as I told you, this limit, the norm of nitrate concentration in seawater, was 10 milligrams per liter, which was this norm is basically if it's more than 10 milligrams per liter, then such concentration already raises some level health concerns. So here you can clearly see that none of the values are bigger than 10, not even close to 10. So it means that all the nitrate concentration in a sea, at least in the points what we chose, are okay and not higher than some specific value. As I said before, you can play more with this attribute table, with this field calculator. It's again up to you, whatever you want to perform. You can untick the edit mode. It again asks you, do you want to save? Yes, we want to save. Now we can close attributes table, and for this, our second exercise is finished. So now we move to the third exercise and the last one, and this one is devoted to sea current field study in the Northwest European Shelf. And for this, what we want to do is we want to display the the current of the sea current, the water current, and to see how it can possibly spread the nitrate pollution even further from the coast into the entire northwest European shelf. So for this, we need again to map more variables, and we go to our plugin. We choose the last one NetCDF file we added, and if you did not add it yet, please do so. So this one, and it has our northward and eastward sea water velocities. So what we do is we click on the first one. This is the zero component, and again we click on add layers. Again, we have a lot of time frames, a lot of depths. We choose only 0, and we choose only 1 because for this now we're gonna map. We won't only map our components separately, both components U0 and V0. After we will need to create a field, a vector field out of them. So it's going to be a lot of manipulations. So instead of instead of mapping this variable for every 15 days of our whole period, we're going to just choose only one time frame, and we choose only 1st of April 2020. So we choose it, we put add and close. Okay, good. And actually here you can see our NetCDF files and layers, our layers what we added. We can see our salinity and our nitrate concentration ones. Here you can see we added one of components of sea current. So we go to another component and do the same. We add layers. 1st of April, depth, everything is good. Add and close. We have them now. So now we have both of our variables, and what we need to do is we need to create a vector field out of them. To do so, we choose them first here on the layers tab on the plugin. We choose one, hold control and choose another one, right click, and we see here a function vectorize. We click on it. Here you see a little pop-up window. Here we choose UV components because it is them. So now we need to match them properly. So here we have, as you can see, eastward one is U0 and yeah, U. Here we put it, and the other one automatically is chosen. As it is a current for us, so we choose current, and downsampling we choose X5. What is downsampling? Well, the downsampling is basically how busy your display is gonna be. So as it's gonna be vector field, we will really see little vectors, so little arrows showing the direction and the intensity of our current. And if we won't use downsampling, it might be that it will be too much, like too many, like it will be too busy, too many arrows on the same place. So we will put downsampling X5 if we won't like it. If it's too much, we will come back and change it, but I think X5 should be okay. So we can choose the name now. Let's put current field, okay, and also the output directory. So we need to save file. Tick. We put current field. Sorry. Yes, we choose only the directory. Yes. Okay, and so now that we click vectorize, yes, it will take some time. Okay, now we see some beautiful arrows are added to our project, and we close. So now we can forget about our plugin for some time. Here we can see let's uncheck it. Here we can see the raster layer of two components, but they don't really give us, a lot of information like this. So we can just uncheck them and not focus on them. What we're interested in is this vector layer, and as I told you, there are a lot of arrows, and we already use downsampling. So at some point, if we wouldn't use downsampling, imagine we use x5, it means that instead of, it means that basically, if we wouldn't use this downsampling now, instead of one arrow, it would be 5 more arrows. So 5 more arrows for each arrow. It would be too much and too busy, the display. So I think like this is quite okay. So what we do now is we need to choose a specific style, for our layer, and we right click on it and we choose properties as we already did. And so now we need to choose a style, as I said. So it's actually this little drop down menu, very down here. So we click on it and we put load style. A new window appears, we choose from file, and now we go to a file. And here you need to choose a directory in which you have specific file, which is called current scale, and the format is QML. So as you will have all the data and all the information for this training, as well as the PDF tutorial, you should know where is it, and you should go there and find it. Let me do it also very quickly. So now I quickly found the file I need. It's this current scale. We click on it, we choose, we said load style, good. We put apply. Now we can see that the style changed a bit. Click on OK, and now, now we see basically the sea current, how it is, how water is traveling in this region, and how our nitrate concentration is spread. Also, what we can see, you can see the arrows directions. So this is the direction of the current, and you see the different colors. And by colors, if you click here, you can see that they also correspond to values. And this is the speed, the speed of the current. So yeah. So to draw some conclusions, we can activate our nitrate concentration layer like this. Zoom a bit to see better, and now we can see how the concentration is spread. Of course, here we don't really see any spreading because the concentration, as we found it, was not very high. So it's obvious that it's not really spread widely. You can see that it's actually slowly, gradually dissolves in the water. So basically, it does not like specifically spread along the current. But yeah, you can literally see how the current flows around along the coast, goes to the bay, go out of the bay, goes here in the in the channel, and travels around. So that was it for another exercise, for the third and the last exercise. So that's basically it for this tutorial, for this training. If you wish, you are of course free to do the same analysis on any other raster layers we already imported, because we chose only one date. It was 1st of April. So if you're willing to, you can check how it is, how high is nitrate concentration during other days, how is it spread, what's the current during these days, and of course you're free to download other Copernicus Marine Service products, other variables. You're free to map and play with them using the using the tools, using the features of QGIS, which we explored here today. So So, as a conclusion, today we learned how to use some specific variables of specific Copernicus Marine Service products to study phenomena of river discharge and also to analyze its impact on the environment. Under this topic, we studied the salinity level of the sea. From this, we found and spotted some major sources of fresh water. And after, we also studied the nitrate concentration in water and the current of sea to see how this nitrate concentration is spread. We learned how to map some raster layers. We learned how to add some user chosen user defined points. We learned how to work with attributes table and calculate some expressions using the information from attribute table. We learned how to create the polygon and how to extract data from raster layer clipped by the extents of this polygon. We also learned how to map our current field, how to do a vector field out of vector components. And yeah, that was all. So now you can, as I said before, you can use any other products to do the same here, maybe on the same region, or you can download corresponding data for some other region and try to redo the process to spot other river discharges along the coasts of different water bodies. So that was all. Thank you very much for your attention. Hope you enjoyed it. And yes, bye. Have a nice day.